We're going to look at finding the point of intersection of two lines using algebra. In this case specifically, the method of substitution. So when we graph two lines and find the point of intersection, the result can be inaccurate. If your lines aren't perfect, they could be just a little bit off, and depending on your graph, you could be off by a factor of 5 or 6 points to 500 or 600 points, depending on the scale of your equations. So we like to use algebra because we can get exact answers with algebra. Now, the substitution method, what it has us do is it has us sub one equation into the other to find one variable. And then it becomes very easy to find the remaining variable. So we'll look at a few examples and see the procedure in substitution. So in this first question here, we have y equals 4x plus 5 and y equals 2. Here we have two different equations, and I've set it up so that it's a little more familiar. The y equals 2 can be subbed in for the value of y. So if y equals 2, we could put that in for y. So I'm going to call this equation 1 and equation 2, and we're going to sub y equals 2 into equation 1. So we just replace the y with the number 2. I'll use a different color here. 2 equals 4x plus 5. And now we go about solving this for x. So we'll move the 5 over. It'll become 2 minus 5 equals 4x. 2 minus 5 is going to be negative 3. And then that equals 4x. And then to get the last part, we can take that 4, move it over, and divide. So we have negative 3 divided by 4 equals x. Now here we have a fraction as our value for x. So this is the x coordinate of the equation. We already know that y equals 2, and we have x equals negative 3 over 4. These two combine to make the point of intersection. So here, we're done. Point of intersection is negative 3 over 4 and 2. So there's our x value that we calculated. There's our y value that we already know. So once we have an x equals or y equals, we're done finding that variable. This is negative 3/4. So this is a fraction. This would be part way between 2 points on the graph. We couldn't get an exact answer like that easily on the graph. We think it was 3/4, but maybe it's not. Maybe it's a little bit more, maybe it's a little bit less. Here we know it's exactly 3/4. Let's take a look at another example. So this is a little bit different now. We're doing substitution, but here we have y equals 2x minus 3, and instead of y equals a number, we have y equals x. So now we have a letter that we're going to have to substitute in. It's done exactly the same way as the numbers, though. We're going to call this equation 1 and this equation 2. And I'm going to sub that equation 2 into equation 1 again. So y equals x, so I'm going to replace the y with the x. So x equals 2x minus 3. So I've replaced that y value with the value that y is equal to. Y is equal to x. It's the same, so I replaced it. Y was replaced with the x. And now I go about solving this. So I already have an x on this side. I'm going to move this 2x over to that side so I can get all my x's on the same side. So I have x minus 2x. I'm going to rewrite that a little bit. X minus 2x equals negative 3. Now x minus 2x, that's negative 1x or negative x. So negative x equals negative 3. And now I can get x equals positive 3. So there's my x value. Now in this case, I'm not done. I don't know what y actually equals yet. I know y equals x. So what I need to do is take this value and sub x equals 3 into equation 2. So I'm going to sub it into this equation and find out what y is actually equal to. So y equals, now x is 3, so if y equals x, that means y equals 3. Now I know my x value and my y value. I know both values. I got my result. Therefore, the point of intersection, x, y. So the point of intersection is the x, y. Now, to further elaborate, we're going to make this a little bit tougher. And here we have an example where y plus 6x equals 7, and we have y equals negative 4x plus 1. So in this case here, we have an equation that we have to sub into an equation. A little bit different, but the same procedure is followed. I'm going to name these 1 and 2, and I'm going to sub equation 1, or sorry, I'm going to sub equation 2 into equation 1. That's y equals. So I know y is equal to negative 4x plus 1. So I can replace the y up here with negative 4x plus 1. So I'll have negative 4x plus 1 in place of the y plus 6x equals 7. And I just subbed that whole equation and put it in brackets just in case there was a number up front that I had to multiply by. I'd make sure I multiply everything through the whole equation. Now I don't need the brackets, so I can drop them. And negative 4x plus 6x, that's going to give me 2x. There's a plus 1 in there, and still a 7. Now I'll solve this for x. I'll move the 1 over and make it subtract 1. And then we'll move the 2 over, and it'll be 6 divided by 2, which is 3. So I found my x value. Now I still need to find my y value. Remember, we're finding the point of intersection, which is 2 coordinates. So I have the x. I can take this now, sub x equals 3 into equation 2. And I'm picking equation 2 because it's already y equals. This one I'd have to rearrange a bit to find out what y is. This one's y equals. I'm going to sub it into that equation. So I have y equals negative 4 times 3 plus 1. So I've substituted my x in there. Y equals negative 12 plus 1, or y equals negative 11. There's my x value. There's my y value. I've now found the point of intersection. It is the x and the y.